Okay. All right, I think we were on example 2. Continuing with the properties of vectors. And we're asked which vectors are parallel to 7i plus j. So 7i plus j means that you will go 7 in the x direction and 1 up. This is that vector. Now, when talking about parallel vectors, you can think back to some of your skills from previous years. And in grade 10, you knew that 2 lines were parallel if they had the same slope. So interesting, when you have a vector 7, 1, its slope is 1/7, because this would be the rise, right? Here's the rise of 1, a run of 7. You would get 1/7. So one way that you could figure out which of the following are parallel is just figure out all of their slopes and look at it that way. So for example, this one, you could take -1 divided by -7, and that would have a slope of 1/7. 0.1 over 0.7 would also have a slope of 1/7. -10 over 70 would have a slope of -1/7. Here, this is 35 over 5, which would be 5 over 35. And finally, 0.2 over 0.14. But the other thing that we're going to do with parallel a fair bit is say if two things are parallel, one vector is a scalar multiple of the other one. So for example, I'm going to take this, I'm going to take the 35, 5 one. And we have the 7, 1. Are they equal? No. They're not equal. But if I put a k in front, and I can choose to put the k in front of either one, I'm going to put it in front of this one. Is this one a multiple of that one? Right? And you can set up mini equations. You can say, okay, 7k equals 35 and 1k equals 5. I wonder what k would have to be. Double check. Does it work for both of them? Yes, it does. That's another way of seeing two things are parallel. What's nice about that is you don't have to like flip things around to find the slope. You're just finding that one is a multiple of the other. So find the value of t so that the two vectors are parallel. And this is using that idea that if they are parallel, then one is a scalar multiple of the other one. And again, you can put the k on either side. I always find that working with vectors is the easiest if you turn them into column vectors. So if I set up one vector as 8t, and the other is 20 and -16, and I put k in front of one of them, doesn't matter which one, then you get the following equations. You know that from the top, the x values, that 8 would have to equal 20k, and solving for k gives you 2/5. If you use that in the second one, you can solve for t, and get t is equal to -32 over 5. So although the slope idea is nice, you're going to find that this idea of one vector being a multiple of the other is even easier. But you could just say, here's the slope of one, here's the slope of the other, and solve that way as well. But where we really are going to start to work a lot is in 3 dimensions. So we can do the same kind of idea with 3-dimensional variables. We've got the vector v. Of course, these are bolded, but you can't tell, so I'm adding arrowheads. Over all of those. So if they're parallel, there exists a k, so that one is a multiple of the other one. Again, change them into column vectors. And I'll often, when I'm showing my work, I'll often go from here, I'll have it in the next step, but I'll often go from here and just write out each individual try to write out each individual equation. So t has to equal 5k, negative s equals k, and 8 equals sk. 5 and s are not the greatest things to use in an example, because sometimes your s's look like 5s and sometimes your 5s look like s's. So what do we have? We have in this middle equation, this is a 5, not an s. In that middle equation, we know what k is, or we can solve for k really easily, that k is equal to -5. Once you know that, you can take the top one and plug in -5 and find out t is -25. And plug in the -5 into 3 and find out s is -8/5. Of course, I could make this a question so that it makes a system of equations with 3 variables and 3 unknowns that you could use matrices to solve. Or just a regular system of equations.